Okay, so this is part 3 of the Tekin Mid-Motor RC10 custom build series. Um, Even though the body and wing are on this, it's not completely done. I was just mocking up how the body might fit and how it would look after everything's all set. I do have a fresh body coming in that I'll paint and make it look all pretty and everything. So from the last time to now, I installed some of the electronics, not all of them, and I finished up the front end, and I also had to make a change to the rear end. Let me go over the front first. So last time I talked about using Traxxas TRX3, essentially Traxxas TRX3 front hub carriers, or front caster blocks, and spindle carriers. These seem to be more readily available than the vintage RC10 parts because Team Associated stopped reproducing those parts. So if you want to get like nice, fresh, new caster blocks and spindle carriers, you can go with the Traxxas parts. You do have to drill out the mounting hole for the hinge pin, but otherwise they fit almost perfectly. And what's great about them is because the wheel axle is metric, then you could use these. See this blue hex here? It's a GPM wheel axle to hex conversion, and it's just a hex with two 5x8mm bearings on either side, on the inside. The wheel axle for this Traxxas unit is a little bit wider than that hex. So what you have to do is replace those 5x8s with flanged 5x8 bearings, and then that pretty much perfectly takes up all the space on the wheel axle. The only problem with these sort of hex units, if you will, is that they do have a bit of wobble, a little bit of play, because for whatever reason, maybe the hex, the actual aluminum part of the hex is a little bit smaller, perhaps, than what you might see on a more conventional hex assembly, like 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 a B5 front hex or something like that. But it does work. I've done the same kind of thing to my Traxxas Rad 2 front end. I've used these same hexes, and it works fine. There's just a little bit of play there. Let's see. So that's all set. Here I'm using a low-profile servo. This is a Turnigy Trackstar. I think it's like a D99X servo. I love these servos. I really normally use high-tech servos for a lot of my cars, and I think they're fantastic. But Trackstar has been coming out with some really interesting products over the last few years, and their servos are actually pretty impressive. This one in particular, it's very, very fast. It's like 0.08 seconds at 6 volts response time. It's very fast. Has decent torque, around 100 to 110 inches of torque. So pretty good, and it's only like 30 bucks. So, I might not expect it to last too long, but because it's so cheap, you can get more of them. And it's low profile, and it fits perfectly fine into this assembly here. You can probably use a standard link servo. It might be a little tight fitting against this angled piece here where the chassis sort of tapers in. It should still fit. The way that this piece works here, this was actually a little tricky. So this is a threaded rod that comes with the Tekin kit. Now you can of course get your own long turnbuckle if you want to, and I think that's what I did on my other Tekin build. But I decided to just use this threaded rod here, and it's such a length that you have to mount the servo with the servo horn over here, right? If you flip the servo over, the servo horn's back here. With the servo horn on this side, you have to use two short rod ends, so these are RPM short rod ends, and you have to tighten them almost all the way so that with this servo horn perfectly vertical, this steering rack is pretty much at dead center. Otherwise, if it's too long or too short, then the steering rack is going to be, like a little misaligned, this way or that way. What I had initially tried to do was to mount this thing upside down the other way with the servo horn facing up back here, and then use two long shank rod ends to make that distance, but it actually wasn't long enough. So I had to go back to this mounting position and use the short rod ends. Yeah, so that's just kind of what that is. If you want to use the stock one, if you If you don't, you can use, again, you get your own turnbuckle of your own length, and you can make this work a little easier. For the battery, this is a little tricky because in a conventional RC10, the battery mounts longitudinally along the length of the chassis, and you have a little battery cup up here, and you can put little foam spacers in to move the battery forward or backward, and everything holds in just fine with a little T-plate that screws in with 2 thumb screws and holds the battery down. On the Tekin chassis, the battery mounts laterally, and this was originally designed for older style nickel cadmium 6-cell packs, and so the full width of this chassis is used to accommodate the full width of that pack. But modern RC cars run shorty packs for the most part. Very few people run saddle packs, unless you're running some vintage 4-wheel drive buggies, for example. So a shorty pack is obviously not as wide. So now you have to think about how are you going to secure this battery in place and have it centered. So there are a few ways to do this. This is the way that I chose to do it. I didn't want to glue like foam spacers on either side to make the correct width opening for the battery, because I was, when you really race something, like if you glue foam spacers on a chassis or something, they might fall out, and then the battery is going to start sloshing around, which you don't want. You want it to secure it in place reliably. So what I instead did was each of these little flaps here, these come as part of the chassis, the build kit, and there's a little screw here that screws in, and that's what this thing hinges on. So I'll just pull this clip out so you can see. Right, hinges on that screw there, and it just comes down and secures the battery. Now your LiPo packs are a little bit thicker than a nickel cadmium 6-cell pack, so this post here that this clip goes in was made to be high enough to accommodate NiCad battery packs, as that was the chassis was designed for. LiPo wasn't even out at the time. So thankfully though, even though this pack is a little bit thick, this brace here is a little bit flexible, and you can just kind of bend it down just enough to fit that clip through, which is fine. And all I did is I took on both sides a servo mount post, and I just drilled a hole through here, and I tapered it, and you just put a flanged, or not a flanged, tapered flathead screw in, and I just mount this servo post here and also on the other side. See, there's another one here. And I measured it out so that when these both come down, it actually holds the battery in place left to right. And the way that I reference that is actually not that difficult. Let's see, if I go this way, you're going to get all shadowing. Let's see, what if I do it this way? Yeah, there we go. So this piece here, there's this little pocket that this screw goes into, and you see one line here and one line here. You take this line right here, and you just extend it back, okay? And that's going to be the center point of where you drill the hole on either side, okay? And then you put those posts on, and it works just fine. Now the other thing is how to accommodate the battery post holes, because these are solid units. And if you use like a 4.2 amp hour shorty pack, those holes are going to fall under this brace, and you won't be able to access the post for power. So you just, I got a routing bit, and I just routed out a little bit of an opening here so I can put, the wire leads into the positive and negative openings there. You don't want to go too far, because then obviously it'll affect the structural integrity of this side of the brace. It could make it like weak along this joint here, for example, and it could snap. So, only go as far as you need to go to make this opening. Another option would be if you run like a super shorty pack, which is like a 2.7 amp hour pack. That's even narrower than this opening. That pack would sit like this. So then you'd have to come up with some other type of bracing to make sure that pack holds in place, because these braces would not even touch the battery. The battery would be like right in here like this. So that would require a different assembly. Maybe you want to get like a plate of some sort that you can mount to connect between these two braces here, so that when it comes down, it just holds everything down. I thought about doing that as well. So, there are options depending on the kind of battery you use. I have plenty of these shorties, so I set up this whole assembly here specifically for these kinds of shorty packs. Onto the rear, installing the motor is a bit of a pain because this is all a really tight area. Even though I don't need this shock tower, because this really was a shock tower originally, because I have a shock tower mounted to the rear here, you still need this to brace the upper gearbox brace to the chassis, okay, to prevent too much chassis flex. So, but the thing is, this kind of gets in the way for how you mount the motor. You can't really mount it from the side, because, you know, there's not enough room here. This gets in the way. Even the chassis itself gets in the way, but it's predominantly this thing here that gets in the way. So you can't just come in and mount the motor from the side. So what you have to do is mount the motor from the front inwards. And it's a bit of a tight fit to actually get it in there. You actually, if I recall correctly, you have to take this out. So you unscrew from the side here, take this thing out, because this little lip here is just enough to get in the way, and then you mount the motor in. And then you come over to this side, and the shock tower, or this brace if you will, it gets in the way for the motor mount screws. So, you know, you either have to come in at just the right angle if you have like a straight hex like this, or if you have a hex with a little bit of a ball end on it, then that'll make it a little easier to adjust these motor mount screws. The other thing I had to do was, after mounting the motor, I realized that the suspension arm was actually hitting against the motor, and it was preventing the motor from sitting straight. The motor was kind of cockeyed. That's because I had the inner hinge pin mounts mounted in the forward position. So instead of this screw hole, it was this one here. And that's the short wheelbase option for these hinge pin mounts. And if you go through the stock Tekin mid-motor build, that's actually how you would have to mount these inner hinge pin mounts to get the active link suspension to line up with the Tekin arms that line up to that active link suspension. You have to use a short wheelbase option. But again, that was designed for older style cars or racing with Nikkei batteries and a DC brushed motor. DC brushed motors have a different shaped end bell, and so there's a bit more clearance between the end bell and the suspension. With a brushed motor, or with a brushless motor, you don't really have that. Motors are a little bit longer, I think, and the end bell is a bit like wider and more flush. So you are going to run into clearance problems. So I had to basically move this all back by, you know, mounting this back a bit using the front hole here and then the front hole on the other side, right there. But what that meant is I had to drill a new hole, yet another hole, under the arm here to mount this screw up into the active link part of the suspension that connects to this arm. Same thing on the other side. So again, you just got to measure it out. What's the offset? What's the distance between these two holes? And then drill another hole forward by that much, so you can mount mount the screw through that correct location there on both arms. Okay. And I had to, I had to try it a few times to make sure I got the alignment just right. But these are very strong arms, so even if those holes are there, it's not a big deal. And then finally, this all works. You know, the arms don't touch the motor as the suspension compresses. Everything is relatively free. The other thing is when mounting these wheels, I think I talked last time about using the Kyosho hub carriers and Kyosho wheel axles and all the rest of it. You can't see it here because the wheel is mounted, but I had to use a wider wheel hex on the rear. If you just use a standard 5mm wheel hex, what you'll notice is the rear width is smaller than the front width when you do the front specifically in the way that I did it with these Traxxas parts and those GPM sort of hex conversion pieces. That pushes the front out a little bit. So in order to push the rear out to get to the same or very close to the same width, you have to use a wider wheel hex. So I used an 8mm wheel hex, also from GPM. That actually, in the past, I used Integy wheel hexes, which were actually a much more difficult fit to these wheel axles for some strange reason. I use those on like my Pro X and my Outlaw Rampage Pro and my Rampage Pro electric conversions, and they work okay, but they're harder to fit correctly. These GPM units fit perfectly onto these Kyosho wheel axles. They're 8mm wide. They're, I don't know, like $10 or so, perfectly fine. But what that ends up meaning is you can't, because you're pushing the wheel out, you cannot use a standard lock nut because there's not enough thread length on the wheel axle to accommodate the nylon ring on the outside part of the lock nut. You have to use a thin, like a 4mm serrated wheel nut. Okay? And you can get, Kyosho makes them, Losi makes them, whoever, it doesn't matter. But the type of wheel nut used back here is going to be really important. So a thin serrated wheel nut, 4mm serrated wheel nut on the rear. And that's kind of where I am for now. I just got to install the speed control, calibrate everything, set up the gearing and the timing and the suspension and all that nonsense. That's just standard tuning. But this is basically it. I think it's going to be really cool. Now I have to basically decide whether I want to run this car the next time I get to go to Vonats, or whether I want to run my Kyosho Pro X. I ran my Rampage Pro electric conversion, the mid-motor version of the Pro X essentially, for 2 years. Fantastic car. I absolutely love that car. I figured I'd give the Pro X a shot, go to a rear motor platform, run that for a few years. But then that was before I built this. And this is just a really interesting car, especially because of that active link suspension. I'm really interested to see how that is, especially when combining it with a hydro drive. You're going to have a ton of mechanical grip at the rear because that active link assures that the wheel always stays flat with respect to the ground. You always have maximum contact patch to the ground. So you combine that with a hydro drive that gives you a bit more of an operating window on a low grip surface. Even if it's a hard packed dirt track, sometimes it's low grip. So the hydro drive is going to help you there. So this can end up being a phenomenal car to race with at Vonats. It's just a question of when. I really want to run the Pro X. I don't think I can go this year, which means I have to wait at least another year to race again. And then I want to run, I have 3 really good two-wheel drive buggies. So it's just a question of which one I want to use. So we'll see. But in any case, this is the build, and I hope you guys learned a thing or two from it. I certainly did. And that's it for now. Thanks for watching.